Neuralink has the big dream of connecting human brains directly to computers. The company was started by Elon Musk in 2016, and it's working on something called a brain-computer interface, a technology that lets your brain talk to machines, and machines talk back to your brain. There are two main goals here. Number one, helping people. Some people have problems like epilepsy, depression, ringing in the ears, or diseases like Parkinson's. In fact, more than 1 billion people have a brain disorder. Neuralink wants to help by stimulating their brains with electrical pulses. For example, the way a Neuralink could help with epilepsy is described by Elon here.
If you've got like severe epilepsy or something like that, it could just sort of stop the epilepsy from occurring. Like it could detect it in real time and then fire a counter pulse and stop the epilepsy.
In the short term, Neuralink is helping paralyzed people control digital devices like robotic arms or computers with just their brains and no hands. And what's even more crazy is they're working on helping paralyzed people walk again. And number two, supercharging humans. In the long run, Neuralink aims to make humans smarter and faster by linking our brains to artificial intelligence. Elon Musk often talks about the fact that our brains are basically just the cortex, or thinking part of the brain, plus the limbic system, or instinctual part of the brain. People may not realize it yet, but everyone also has a third brain layer. That is the layer of technology and our digital devices. See, brain implants help humans merge with machines. Imagine downloading knowledge like in the Matrix, or thinking faster than ever before. They want to make these devices available for anyone who wants one, and they expect billions of people will get these in the future. The idea is based on how your brain already works. Your brain has about 86 billion tiny cells called neurons. These neurons send electrical signals to each other to make you think, feel, and move. Neuralink's job is to listen to those signals and talk back to them using a tiny device implanted in your skull. The Neuralink device is a small, coin-sized gadget that sits in your head. Here's how it gets there and what it's made of. The first is the implant. The device itself is called the link implant. This is the piece that replaces the cutout piece of skull. Inside this tiny package are 4 tiny chips that quickly process what's happening in your brain. It's powered by a tiny battery that can be charged from outside your head. You don't even have to plug anything into your brain. The link is designed to be super safe and not hurt you. And the second thing are the wires, or electrodes. Attached to the implant are dozens or even hundreds of tiny flexible wires called electrodes. These are made of metals like gold or ceramics like silicon carbide, and they're way thinner than a human hair, about 5 micrometers thick. For comparison, the average human hair is about 15 times thicker. They're super small because they need to sneak into your brain without causing damage. The brain is soft and squishy, and we don't want these breaking or hurting anything. They have to be flexible and move around with the brain as the meat jelly sloshes around. So even though these are made with hard materials, the threads are so skinny that they become flimsy, like string. The third part is the robot that performs the surgery. To implant the device, doctors use a custom surgical robot. So you might be wondering why Neuralink uses this instead of an experienced neurosurgeon. It's because a robot is much more precise than a shaky human hand. The robot is like a high-tech sewing machine. It uses cameras and lasers to map your brain and place the electrodes exactly where they need to go. It's so precise it can avoid blood vessels and keep everything else safe. The robot drills a small hole in your skull, then carefully inserts the electrodes into the outer layer of your brain called the cortex. This is where a lot of your thinking and movement actions occur. The surgery is meant to be quick and safe, just as simple as getting a piercing, but this is sewing stuff into your brain. The fourth component is the software. The AI that runs Neuralink is a big deal. It's like a translator between your brain and the computer. It learns from you over time, getting better at understanding your unique brain signals. Once it's in, the implant connects wirelessly to a device outside your head, like a phone or a computer, using low-energy Bluetooth. This means no messy wires sticking out, just a smooth, hidden connection. If you're enjoying this episode, please subscribe on YouTube and follow on X. Now let's get back to the fun part, how Neuralink listens to your brain and talks back. Listening to the neurons. Your neurons talk by sending tiny electrical signals. When you think, move my finger, a bunch of neurons fire off signals in a specific pattern. The electrodes in the Neuralink implant pick up these signals. They're like little microphones stuck right next to the neurons. Each electrode can listen to a few neurons at a time, and with hundreds or thousands of electrodes, Neuralink can hear a lot of brain chatter. These signals get sent to the implant, which turns them into digital data, like ones and zeros, and beams them wirelessly to a computer. Understanding the signals. The computer uses smart software, AI actually, to figure out what those signals mean. For example, it might learn that one pattern means move my arm, and another means click a button. This takes training. In early tests, patients think about doing something, like moving a cursor on a screen, and the system learns to match their brain signals to the action. Talking back to the brain, Neuralink isn't just about listening. It can also send signals into your brain. How? The electrodes can zap tiny electrical pulses to stimulate neurons. For example, if someone is blind, Neuralink could send signals to the part of the brain that handles vision, making them see basic shapes or lights. It's like drawing pictures directly in your mind. A real-life example. In 2024, Neuralink tested this on a human for the first time. A person who couldn't move their arms or legs got the implant, and after some training, they used their thoughts to move a cursor on a screen and play chess without touching anything. That's the brain-to-computer magic at work. And going back to what I mentioned at the beginning about helping paralyzed people walk again, many people don't understand how this works, so I'll explain it simply. People who suffer a spinal cord injury simply have broken wiring. The signals from their brain are still being sent to their arms and legs, but the wires are broken and the signals can't get through. But Neuralink gives them hope. If they get a Neuralink in their brain and another one below the spinal cord injury, the link in the head can grab the brain signals and wirelessly send them to the link in the spinal cord. It's still being tested, but the idea is to make it so people who couldn't walk before can stand up and take steps again, all because their brain gets to be the boss once more. I also created a more in-depth explanation video that I'll share here. Neuralink is making big strides towards the wild possibilities. They started with rats, then pigs, sheep, and monkeys. Pager, the monkey, played video games with his mind, and other tests showed pigs sensing touch via brain signals. The US Food and Drug Administration gave the green light for human tests in 2023, a big step for safety and legitimacy. In January 2024, the first human got a Neuralink implant. This participant, named Nolan, is paralyzed from the neck down. He used it to control a computer cursor and play chess just by thinking. No major side effects were reported, however, some of the threads began coming out. Fortunately, the brilliant Neuralink team was able to fix this issue with software and prevent it from continuing in the future. The current implant reads from 1,024 electrodes, but Neuralink's working on versions with more than 10,000 for richer data. They eventually want to get to millions of electrodes to listen and talk to all parts of the brain. It's still experimental, focused on safety and basic function, but the proof of concept is there. As of March 2025, Neuralink has implanted their device in 3 humans. These surgeries were all completed here in Phoenix, Arizona, but now they're expanding to more hospitals, including one in Miami, Florida, and others internationally. They will perform surgeries in Toronto, Canada, soon before moving on to the UK, New Zealand, and UAE. The team has helped these 3 paralyzed people regain their digital freedom by helping them play video games with just their minds. And they aren't stopping there. Neuralink's second product will help blind people see basic things to navigate the world. Neuralink is also building a large clinic in Austin, Texas, so that in the future, people will be able to walk in and get a Neuralink within 10 minutes. The team has huge goals, but they'll first have to overcome many challenges. The first one being safety. Putting tech in your brain is risky. Neuralink has to prove it won't cause infections, it won't damage your brain tissue, and won't stop working over time. After all, the brain is a very salty and difficult environment that isn't well suited for computer technology. Building all this is tricky. Neuralink had to invent new ways to make electrodes tiny yet strong, and they're still working on making the implant last for years without breaking down inside your body. Also, you wouldn't want a scenario where you get a Neuralink and the company happens to go bankrupt. Fortunately, I personally predict that's unlikely, but I suppose you can never be too careful. There are also many questions being asked about ethics, like who gets to have this tech first? Could it make some people superhuman while others can't afford it? And what happens if some creep hacks into your head by turning your thoughts into their personal playlist? Plus, there's the creepy vibe of governments and corporations peeking into your noggin. And then there are also societal challenges. Neuralink could change medicine, letting people overcome disabilities in ways we've never seen. It will also redefine what it means to be human. Right now, we're just our brains, paired with our biological bodies. Once we merge with our digital devices, we'll become true cyborgs. So remember, Neuralink's short-term goals are to help medically with people who have spinal cord injuries move again, and give sight to the blind by stimulating the brain's vision center. They're also testing it for diseases like epilepsy to stop seizures or depression to boost mood. They're making real progress. So far, they've done a few human trials and shown it works for basic tasks like controlling a computer, but it's still experimental and safety comes first. They also have long-term dreams like brain upgrades. Imagine linking your brain to the internet. You could think a question and get the answer instantly, or control smart devices like lights and cars with your mind. Think about a super advanced version of Grok 5 years from now paired with an advanced Neuralink, or a Tesla robot vehicle paired with an advanced Neuralink. This is what Elon Musk has been talking about since he started Neuralink. We need to merge with AI in order to go along for the ride. If computers get smarter than us, Neuralink could make our brains faster and more powerful so we don't get left behind. Elon often says Neuralink's mission statement is, if you can't beat 'em, join 'em. I explained all the important parts of Neuralink, but there are many more details to learn about how this technology will unfold. For more videos, I have a channel dedicated to providing news updates and information about Neuralink. It's called Neurapod, which you can find with the link in the description. Please follow on X and subscribe on YouTube. My name is Ryan Tanaka. Thanks for watching.